Alright, so here it is. Lunar Loo, toilet for space, day 1. So we all do it. We all have to go to the bathroom, and that's no different in space. But it is quite a different process. And what NASA is asking to do is they are inviting the public, they're inviting us to submit our designs for a new toilet to go to the moon. Ready for some moon pooping? First thing we need to do is find out what the specifications are. And I have those down, so let's go ahead and take a look at them. Alright, so I took the liberty to go ahead and start putting together a PowerPoint here. And so taking a look at it, I kind of like the front design that we have here. Kind of hits the spot. But anyway, for what I want to capture is the design requirements. What NASA is looking for at minimum to have. So the biggest thing is it needs to function in both microgravity and lunar gravity. It has to have a mass of 16 kilograms or less, and that's Earth's gravity. It cannot occupy a volume any greater than 0.12 meters cubed, and roughly that's about 1.5 by 1.5 by 1.5. Can't consume more than 70 watts of power. Can't be louder than 60 decibels, and that's about the average of a bathroom fan. Can you believe that? So it has to be able to accommodate both male and female. They have a height requirements and a weight requirements. And as when you get down to the performance requirements, so they have amounts that you need to have it be able to hold. A certain amount of urine for so many days with so many people using it so many times. Fecal matter, in case they get sick, diarrhea, they gotta have that in there. But they also want it to be able to hold toilet paper, wipes, gloves, feminine necessities, and all the good stuff. So they're going way above and beyond what the actual toilet on the space station can do. But they want it all in a smaller package, use less power, and yeah, we'll see. So since urine is acidic, they want to be able to stabilize it so it doesn't off-gas and produce gases that you really don't want to have in a confined space in a spacecraft, if you know what I mean. So we got to find a way to stabilize it, and it needs to be easy to clean. No one wants to be in space cleaning toilets all day, right? So they want a 5-minute turnaround between uses. So they want it to be bing, bang, doom, done, next person comes in, ready to go. So they want to be able to also allow for the transfer of the waste to storage, or provide for external vehicle disposal, dump it into space. You know, all these are kind of the minimums of what they want to do. You can go above and beyond and do extra stuff, but to be honest, I think in our time frame, we're kind of going to be limited on what we can actually achieve. So the next one is we have to account for system failure. So what if it just completely fails? They don't want waste matter coming out toilet everywhere, because then you got to go chase it down. They don't want crew exposed to that, and they don't want the crew exposed to the vacuum of space. So those are probably some really good ideas. And we got one bonus feature that if we can accommodate vomit without the astronaut having to stick their head in the toilet, we get bonus points. They're trying to capture all the functionality of the toilets we use on Earth in space. That's going to be difficult to do, especially in the microgravity part. In the lunar gravity, I can see it being somewhat possible, but microgravity is going to be a little bit of a challenge. Yeah. The timeline I have not set. what I'm planning on doing here is, once we figure out where our challenges are going to be, we're going to make a timeline on the time frame that we need to complete those steps, so that we can assure that we complete the project by the deadline. Because if we do all this work and we don't get it submitted by August 17th, 2020, then honestly we just kind of wasted a bunch of time. So start day, day 1, July 16th, 2020. Deadline, August 17th, 2020. Something tells me we should really get started. Yeah. So one of the hardest things I've noticed on any project, it doesn't matter what it is getting started. It's taking that leap. It's jumping in so that you can fail early, so you can get to the end with something successful. And we can't be afraid to fail, because it's inevitable. We're designing something for an environment that we honestly have never been in. Very few people have been. So it's kind of hard to wrap your head around on how everything's going to work in that type of environment of microgravity or weightlessness. So we really have to start thinking outside the box and come up with creative and inventive ways to achieve certain functionalities within this toilet. Now, I've already had probably about a couple days to start thinking about this project, and kind of some of the processes and some of the ideas on how we're actually going to be able to design a toilet for space. And I did go ahead and jot down some of the challenges that I think we're going to have to conquer or overcome to be able to achieve this. One thing is it has to operate in both microgravity and lunar gravity. So what that means, lunar gravity is easy. It's about 1/6 of our gravity, but it is still gravity. There's something there to pull everything down, if you know what I mean. But when you get into the microgravity, it just kind of flies wherever it wants to. And well, they have a process that they use on the space station, but it uses fans, and one of the requirements for this project is that it cannot use more than 70 watts of power. And I think I looked it up, and it was currently using, man, almost 2,000 watts of power on the space station. So yeah, we definitely can't do that. So we're gonna have to really scratch our heads and kind of think of how we're gonna do this. So how about we go to the drawing board and see what we can come up with. Thoughts? Toy, right? Let's go. Sorry. Maybe we combine a fan with like this auger screw type of compactor. What I want to do is I'm going to come back on the next video, and I'm going to have 3 ideas. So 3 different ways we can achieve the movement of the waste in a microgravity setting. And what we'll do is we'll decide from there on which one will be best based on all of our other requirements. All right, so we're gonna wrap it up tonight, and if you want to help me out, submit your 3 ideas on how we can move this waste matter in microgravity, and let's see if we kind of match on what we're thinking. I'm thinking some type of fan, or maybe a screw type compactor fan, maybe. And you know, I really don't want to separate them, but I think separating the liquids from the solids might be best in the long run. But I don't know. Let me know what you think. Put in the comments below, let me know. And I'm not going to ask you to subscribe, but if you want to follow me along, then you know what to do and you know where to find that button. It's probably somewhere down here. Yeah, and down there it's got a little bell on it. So again, I thank you for joining me on this Daniel K vlog, and we're gonna see if we can design a toilet for space. So until the next one, which shouldn't be long, we got a lot of stuff to do in a short amount of time. I'll see you next time. Later.